Every knowledge base we have ever built rotted in 90 days. The links break, pages go stale, search returns nothing. We used to fix that manually. We stopped. Hi, I am an avatar for Dr. Terry Byrd. Dr. Byrd is off discovering new ways to make your second brain development so much more valuable in your everyday life. In this video, we will show you the system we built so JARVIS, our second brain development project, identifies its own gaps, drafts its own fixes, and waits for our approval before touching anything. Phase 7 of the second brain. The promise at the end of video 6 was one sentence: JARVIS improving itself. Today we close the loop. JARVIS watches the wiki. JARVIS proposes changes. I approve. Everything commits to Git. Here's the problem nobody talks about. Your AI doesn't break. The knowledge around it breaks. Day 1, your wiki is fresh. Every link resolves. Every page is recent. Every search returns results. Everything is working perfectly. Day 90, same system. Zero maintenance. Links rot. Pages go stale. Searches return nothing. The agent works fine. The surface underneath it has decayed. Now your whole second brain collapses. 3 forces cause rot. You think everything will remain as it was before. Therefore, you stop editing because you already know the information. In today's world, things can change very, very quickly. New technologies, new laws, new changes of all kinds, and thus new terminology emerges that your pages never mention. If you could see inside your system now, it would appear much different than before. The external sources you synthesized from change underneath you. Each force is slow and invisible. Stack them, and at 90 days, your search is worse than useless. The fix is a closed loop. The detectors surface the rot as data. A large language model drafts the patch. We review all the change and approve them if appropriate. The applier writes, commits, and reindexes everything. Then the detectors run again. The only required human step is approve. Everything else runs without us. That's phase 7. This is the Improvements tab, new in the command center. 4 columns: pending, approved, applied, rejected. Every proposal the system surfaces lands here. Every decision I make is tracked. Every applied change is a git commit with a proposal ID in the message. 41 rows in mine right now. An important component of this improvement mechanism, as we have seen, is the detectors. We have 3 types of detectors which might signal problems. These are, for number 1, stale pages. That is any wiki page not edited in 90 days. The second one is broken links. Any wiki link pointing at a file that doesn't exist. Last, the search miss. Any FTS query that returns 0 results, logged automatically. All 3 are pure database calls, no LLM call. Here are 2 of my fellow avatars discussing the issue.
We have 3 detectors. We have pure database queries. That makes this complete, right? Wait, why not use a large language model here? Because rot detection doesn't need reasoning. A database query runs in milliseconds, costs 0, it catches 95% of the signal. Save the large language model for the drafter.
The first time we ran the broken link detector on our Claude Code wiki, it surfaced 14 real findings. Pages like MCP versus CLI, linking to MCP servers, a page we had never written. These were real gaps hiding in plain sight. The detector doesn't fix them, it just makes them visible as data. Search miss is the sneaky one. Every FTS query is logged silently. If the same query returns 0 results multiple times, that's a content gap. People need that topic, but the wiki doesn't cover it. No other detector catches this signal. Only the users of the wiki know. Our detectors find the problem. Then the drafter writes the fix. When we approve a proposal, JARVIS spawns a Claude subprocess using the CLI and my OAuth token. By the way, all of this is at zero API cost. Now, that subprocess reads the target page, reads the raw source material, and writes the actual diff. It has my full JARVIS context. All of it is available. Our wiki, skills, memory, everything. The problem can be resolved with the maximum resources at JARVIS disposal. Every proposal opens in a detail modal. Type, target, rationale, evidence, the raw signal that triggered it. The diff field starts empty. You see the menu selection at the bottom of the pop-up window. To get the diff, use the Draft with AI button. When we click Draft with AI, the drafter fills it in, the diff location. We can scroll up and down on the diff. We can edit the diff right in the browser. Then we approve it. You can see when the pending improvement is approved, it moves to the approved column. If we apply it now, it would move to that column. 3 clicks, fully reviewed. Apply does 4 things. Writes the diff to disk. Stages and commits to Git with wiki update foo proposal number 42 in the message. Triggers an FTS reindex so search finds the new content immediately. And marks the proposal applied with a timestamp. The whole pipeline takes under 2 seconds. The safety story matters. Nothing JARVIS touches is silent. Every change has a proposal ID. Every proposal has a reviewer trail. Every write is a discrete git commit, so rollback is one command. We feel we can relax because the system cannot rewrite content without us saying yes. One addition to JARVIS is more subtler. JARVIS scans its own chat history with me. If I keep asking the same thing in different words, that's a pattern. A Jacquard similarity clusterer groups them. 3+ matches in 30 days emits a proposal to extract that intent into a reusable skill. I stop retyping the same instructions every time. The system tracks external domains JARVIS cites. If the same site shows up 5 or more times in a 30-day window, that's a signal. We are relying on it, but we are not crawling it yet. A proposal surfaces. One click adds it to the weekly docs crawl with an auto-inferred strategy. bun.sh has been proposed as a crawl source this week. One more detector added this week. Every wiki has an index.md. The wish list. The broken link detector skipped it because it's a meta file. We extended the scanner to read the index specifically. Every link pointing at a page that doesn't exist becomes a proposal. 24 appeared on the first run. Each one is the page you said you wanted to write. These are topics that evidently are of interest, but have not been explored yet. Now the proof. We built the infrastructure, then we used it. This week we added a 3rd wiki to the system, AI Filmmaking. Watch how every piece of Phase 7 participates in scaffolding a brand new domain, from 0 in 1 session, while the detectors are already running. Scaffold first. 6 category folders, models, platforms, techniques, prompting, pipelines, experts, plus a hot cache, an index, a log. Then crawl. We pointed the system at Runway's API docs and Help Center. 144 pages pulled in, 1.2 megabytes of raw material, 0 of it written by us. However, this crawl got everything wrong. Docs.runway.team isn't Runway ML. It is a mobile release management company with the same name. 100 pages of App Store Connect and Fastlane docs landed in our AI Filmmaking wiki. JARVIS caught it, discarded the collection, and removed the crawl source. Same system, the crawl sources tables, made the fix reversible. The system was able to discard it with one simple move. The drafter did the heavy lifting. We gave it a prompt. Synthesize these 144 raw files into wiki pages. 10 minutes later, 17 grounded pages existed. Every claim cited a source file. Every page under 800 words. Full cross-linking. Runway's real pricing, its actual model list. The explore mode mechanics, all captured. We picked 5 priority proposals, the ones we actually needed for Byrddynasty production. Camera moves. The Byrddynasty long-form pipeline. Script-to-shot list. Seedance prompting patterns. One subprocess. One batch prompt. 6 minutes later, 5 new pages existed in our wiki. 4,184 words, all grounded, all cross-linked. The end state. 17 wiki pages in the AI Filmmaking wiki. 10,000 plus words. Every claim traceable to a raw source. 3 wikis now indexed in the command center. Cross-references resolve. Search works. The new wiki behaves exactly like the original ones, because the registry pattern let me add it in one config entry. This is the real insight. We didn't write a maintenance script. We taught JARVIS how to maintain itself once, and now the maintenance runs while we do other things. Detectors catch rot daily. The drafter turns gaps into proposals. We approve when we have 5 minutes. The wiki gets stronger while we are away. Phase 7 is finished. 3 things are next. Contradiction detection, catching 2 pages that disagree on the same fact. Cross-wiki bridges, propagating a concept learned in one wiki to another when it's relevant. And an auto-apply tier for the low-risk changes, where I only see the ones that need judgment. We first ship Phase 7, then extended in Phase 8. If this is the kind of thing you want more of, architecture-level AI workflows, not prompt tricks, subscribe and hit the bell. Like if you've got one idea you'll actually use. Share with the one friend who's been building their own agent stack. The more this channel grows, the deeper I can go on each phase. As they say, Phase 7 has been shipped. JARVIS now watches its own knowledge, proposes its own fixes, and waits for us to approve. The system is a data-structured conscience, every change visible, every change reversible, every change ours. Next video, we will show you what we built with it.